Hi, this is Danny Tang. I'll be doing the probability and stochastic homework 3, problem 2, and we're given a probability density function f of x equals e to the negative x plus 1 times unit step function x plus 1. And we're also given y equals g of x equals absolute value of x from -1 to 1 and 0 otherwise. And the problem asks us to find the small y of f of y, the capital F of y, which is just a PDF written in terms of the variable y. So before we do anything else, we should look at the g of x function first, and the graph we're shown is this. From -1 to 1, you have the absolute value function, and it's 0 otherwise. And from this graph, we can see that on the y-axis, the function only exists from 0 to 1. So keeping this in mind, we rewrite g of x in terms of x equals y instead of y equals x, and we get y negative y from 0 to 1 and 0 otherwise. So now we can use the fundamental theorem to find the small f of y. Small f of y is equal to small f of x over absolute value of derivative of g of x. And we see that the absolute value of g of x, or derivative of g of x, is actually x over x absolute value, which is 1. And when we put this into the theorem, we just get the same function with x equals y, x equals negative y, and 0. So now we can write f of y, small f of y, equals e to negative y plus 1 plus e to the y minus 1 on the interval 0 to y, or 0 to 1 on the y-axis. As for y equals 0, we have to find the impulse function, which is from 1 to infinity of the density function. And we actually get this equal to negative x plus 1, from 1 to infinity, which we then get to be e to negative 2. So now we can also write e to negative 2 when y is 1, or y is 0. So this is what we get for small f of y, and to graph it, which is just at 0, this is small f of y, we get this impulse function. Oh, I forgot to add this. Oops, y. And now we see that there's an impulse function here, e to negative 2, and then to 1 we get this function, 0 to 1, which is approximately here. So then we just draw 0 everywhere else, and we get this. And to find capital F of y, we just take the integral of small f of y. So we do this part first. 0 to y, f of y. We use a dummy variable beta here, so we don't confuse the two y's, since we want to replace this, the variables in here with y. So we get 0 to y, e to negative beta plus 1, plus e to the beta minus 1. So after we do the workout here, we actually find this to be negative e to the negative y plus 1 plus e to the y minus 1. So that's just for this part. And then for the impulse function, you just add it to this. So what we would get is negative e to negative y plus 1 plus e to the y minus 1 plus e to negative 2 on the interval 0 to 1. And then since this is a distribution function, we know that it has to equal 1 past 1. So 1 y greater than 1 and 0 1 y smaller than 0. So this is the function we get. And to see the graph, once again, draw the y-axis. This is 1 big Fy 1, and we have this function. It goes to 1 here after 1, so that's 0. So there we go. Or actually, I don't really know what this is, but yeah. So that's the capital F for Y.